Hello, and welcome to Math 121. This is a video over section 1.3, and what we're going to be talking about today are quadratic functions, okay? And our objectives today, we want to recognize the characteristics of parabolas. We want to be able to graph those parabolas, determine a quadratic function's minimum or maximum value, and then solving problems involving quadratic functions' minimum or maximum value. So, let's talk about the characteristics of a parabola. And what I want to do is just draw a quick graph here, okay? And I'm just going to draw a generic parabola like so, okay? One of the things I want to talk about is a couple points. This point here, these points here, and those are some of our important points. So the point down here, we called this the vertex, okay? And the vertex is either going to be a maximum or a minimum value, okay? And we'll talk about how to obtain the vertex. These points here, okay, are called your zeros, okay? And these are solutions to the quadratic. Okay? And so let's look at something else here. All of these graphs are of the form y equals a times x minus h quantity squared plus k. All right? And what I notice about this is that I got a couple different values. My vertex is found at the value h comma k. All right. So this is we call this here, we call this vertex form. Okay. So this is vertex form. Okay. We can identify my vertex if it's in this form, if we have a quadratic in this form. It's not always in this form, but if it is in this form, what I notice is that this value here, h, is my x value of my vertex, and this value, k, is my y value of my vertex, okay? Now, a is an important number, okay, here. A does a few things. It either stretches, or it's going to shrink the graph, okay? Also, what I know is that if a is positive, if a is greater than 0, okay, then the graph opens up, okay? If a is negative, if a is less than 0, then the graph opens down. Okay, and this is true for any leading coefficient. You know, any number that you have on the very front part of your parabola. If your leading coefficient is positive, then the graph is going to open up. If the leading coefficient is negative, it's going to open down. Now, what this also means is that if the graph opens up, okay, you know, it's going to look like this, okay, that means that you're going to have a minimum value at your vertex, okay? If you have this example where the graph opens down, okay, then your vertex is going to give you a maximum value, all right? And so that's the idea, okay, of all this. And so what I want to do is just go ahead and take a look at this and graph this quadratic function as such. And the thing that I need to see here is that, you know, I want to identify my vertex, okay, and I want to identify my maximum, whether it's a minimum or max, okay. And so my vertex, given my numbers here, this is my h and my k, all right, is going to be the value 1, 4. That's going to be my vertex. All right, so I'm going to plot that point here. So 1, 2, 3, 4 is here. Okay, and then my a value, a is equal to -1. Okay, so therefore, what that's going to do is that's going to make sure my graph opens down. All right. And so what I know is I'm going to have these points here, and then it's actually going to cross the x-axis here and here. And I'm going to have a graph that looks like this. Now, the other thing is that you guys can put this into your calculator and just graph and find those points. But what I want to make sure I know is that these are my x-intercepts. Okay, so my x-intercepts are the points 3, 0, and the points -1, 0. Okay, and then the other thing that I have is my vertex here. So this is my vertex. It's also my maximum value, okay? And when I say maximum or minimum value, that's like my maximum y value. What's my largest y value? You know, for a maximum, if I have a minimum value, that's my smallest y value, okay? And that's the idea, all right? So, you know, that's kind of the idea. The other thing I want to do, if you want to find the vertex, okay, so the other thing here for your vertex is the x value. So let's think about this. Vertex, let's say it's not in vertex form. Let's say it's in standard form, where you have a function like this where it's ax squared plus bx plus c. Okay, this is called standard form. All right, and what I would do to find my vertex, the x value of my vertex would be the opposite b over 2a, okay? So I take these numbers here, if my function's in vertex form, if I take that and I have a, b, and c, okay, and these are just my coefficients, and this is my constant c out here, I take the opposite of my b value, divide it by 2a, and that gives me the x value of my vertex, okay? So this is the x value of my vertex. Now, if I wanted to find the y value of my vertex, I would simply take f of negative b over 2a. Okay, and I plug that number in, I plug that x value into my function, and it'll give me my y value. This is my y value of the vertex. Okay, so go ahead and finish out these problems. That should be and that, guys, will tell you your maximum or minimum value, okay? But there's just a lot of things that we need to be able to look at these functions and kind of know what they're saying and know what they're going to do, and such as. So, I enjoyed making this video. I hope you enjoyed watching it, and we'll see you soon. Thanks a lot. Bye.